Let's take now the result of an example. Here's the example of the evaluation of one powerhouse on a system, in which on the left-hand side here we have without adaptation. Climate change has taken place, but we're kind of operating blindly. And we see here, amongst the 10 different scenarios, we get change in productivity of anywhere from 0 to minus 14%. Whoa! Now, mind you, we're not making any adjustment to operating policies. Then let's see if what happened if we make some adjustments to operating policies. And again, you're going to use mathematical simulation and optimization technologies to identify those appropriate ones. And here, in this case, there's been 10 different evaluations, and every one of them had different operating rules. But they're optimal operating rules relative to the anticipated change. Ah, beautiful. We're getting increases from 1 to 15%, an average of about, let's say, 8%. Now, let's compare these two scenarios. Do nothing and do something positive. Well, the difference between the two of them is almost 19%. So it's important to acknowledge that we have to make changes. Now, let's take a look. Let's make some non-structural changes. What can they be? They can be, the first one, we can influence the energy demand. We can influence the pricing that is being charged for energy in order to maybe have an impact on reduction of demand in order to be able to operate better. We can bring a rule changes in the way we operate. We can develop better hydrological forecasting methods, which take into consideration the changes in climate. And in some cases, rather than forecasting the impact of a rainfall or a snowfall, we're going to be dealing in a different situation with different temperatures and such like. And maybe the technology will even have to be changed. Well, then let's go next step forward, and we're going to be coordinating the operation of the project. And not only coordinating the operation of the hydroelectric project within itself, but admitting that that hydroelectric project is part of a watershed and a part of a family of water users. Now, in our particular case, we don't have irrigation, but I mean, you take in the southern United States where this would be happen. Well, there's other needs for water for irrigation. So we have to let's better coordinate the use of water in this respect. And we have to develop technologies to evaluate the performance of the project and to identify new operating rules. This will have to be an ongoing, continuous process over time. It's not like we're going to find out what to do now and we're going to do it for the next 50 years. No, it's a dynamic process. And in so doing, we'll have to maybe consider making some modifications to design procedures. Now let's go one step forward. Let's go from not only changing the way we operate these systems, let's see if we can make some physical changes to them. Well, one of them would be saying, okay, we've got 2 or 3 rivers here, and this one has got a little bit of free capacity. Let's divert some water from one watershed to another. Let's create another upstream reservoir to capture some of these increased variability of flows. Let's increase the capacity of spillways in order to be able to handle flooding so that our reservoirs don't pop up too high of a level when we get strong inflows. Let's design the dams in such a way that we can make structural changes as time goes by. For instance, we'll build a dam and then we'll build a section with an overflow spillway. But we're going to put some pillars in there or columns in there such that when it comes later on in time, we can slip control gates in it. This is kind of adaptive measures. Let's modify the dimensions of canals. Well, we're going to have maybe in some cases greater quantity of water. Those canals were not designed for that. They were designed for the hydrological conditions of the 60s. So we may have to change the dimensions of the canals in order to, again, in some cases, reduce the hydraulic losses between the reservoir and the powerhouse. We could also consider changing the characteristics of the electrical components, the generators, the transformers, the transmission lines, change the capacity, the capacity of the turbines. Now, why not a combination of the two? That is structural and non-structural adaptation. Well, for existing projects, one of the ways of doing so is, well, let's first of all implement changes to operating policies. One of the great advantages of making changes of a non-structural nature is they do not require heavy capital investment. And they are also flexible. If you design one today and it doesn't quite work out, well, fine, we can make a change a little bit later, but compare that with somebody who spends $100 billion on something. It's there and badly evaluated, and it didn't work out. So I'm very much in favor of putting a strong accent on the question of implementing improved operating rules, getting to know what is happening, what nature is doing, what can we do about it, and what is the impact upon this. Well, of course, we can, for existing projects, as I've said before, we can upsize the characteristics of certain things like turbines. Turbines get replaced maybe every 40, 50 years anyway. Well, instead of putting in the same type of turbine that was put in there 20, 30, 40 years ago, put in a more modern turbine, maybe a little bit more powerful, having different efficiency characteristics. Changing physical elements within the project compatible with the new hydrology and the new objectives. For new projects, of course, we should develop and apply new design criteria. Don't develop and design them like they were in the 60s. That was fantastic. We were building fantastic developments in the northern part of Quebec, and they're wonderful projects, and they're working very well for us. But some of those criteria were not appropriate. And some of them didn't also perhaps adequately take into consideration other matters, environmental, social, and such like. So let's see if we can't incorporate this into projects. So we now see, very quickly, I'm trying to present this thing as fast as possible in many respects. What has been happening is we are getting, first of all, changes in climate. It's recognized, but very fortunately, from the mathematical modeling of climate change impact upon hydrology, there has been, in the last few years, significant improvements in the modeling techniques. Regional climate modeling is just one. I'm going to open parentheses. Hydro-Québec has been conscious of the need to consider climate change, and they have been conscious of this now for the last 20 years. In the last 10 years, about 10 years ago, they created, with cooperation of the government and a few other agencies, Uranus, which is a research-based group in Montreal, in which there are 250 people operating through universities, etc., dealing with the question of climate change, not just on hydro, human issues, health issues, municipal issues, etc. But Hydro-Québec is conscious of the importance of supporting this action plan. And I'm almost of the belief, and I'm glad to be contradicted if what I'm going to say is wrong. I wouldn't be the least bit surprised if we were to do an evaluation across Canada, North America, and maybe even worldwide. Hydro-Québec is probably out front in terms of effort and acknowledgement as a private institution. We're not the government. Okay? This is private, in some respects, it's a private institution, whatever. So closing that aspect and going back to this question of climate science has changed. We have now available technologies and knowledges which are sufficiently mature to be used. Let's use them. Let's evaluate a multitude of climate change scenarios. Let's acknowledge that there is a level of uncertainty which is associated with these evaluations, and that we must take them into consideration. We must not just decide like that based upon a global thing which says, inflows are going to increase by 20%. Let's apply it. It's more complex than that. What about the question of the conclusions relative to impact and adaptation? Well, as I said before, there's an evidence of climate change taking place, and it's having an impact upon water resources. This evolution of climate change is impacting directly upon the hydrological regime, and of course, impacting directly upon our hydro projects. For existing equipments, we recommend that we revisit the operation to consider climate change impacts. Now, what I just said is the same thing, but I think that other people who are interested in irrigation and the such like should be doing. I'm just bringing forth an example of what is being done in the Hydro-Québec industry relative to hydro projects. So the future equipment should be designed to be adopted, operated adaptively. That is to say, now, and we continuously modify the way we operate the system, and if necessary, make some changes as well. Here's an important point which I think most of you are very concerned about, and that is the question of organizational changes. It's necessary to develop and apply policies that take into consideration climate change and are compatible with global efforts to adjust to climate change. And that may require cooperating with various agencies, cooperating with the government. It may require them to make some changes too, in order that the collectivity is effective, and we are part of it. We strongly recommend that there be a strong maintenance of research and development work applied to climate change, hydrology, operation issues, and I'll extend it, even if it's not on the slide, the question of physical adaptation. I mentioned that there's a research group, very, very highly qualified individuals, who are carrying out studies. If those studies just pile up on a desk, no value. So it's essential that adequate communication is developed between those who are doing research, even like this association, which I admire very much, who is promoting the concept of adaptation. And there has to be developing, that we close this gap between those people who have to make operating decisions, those people who have to plan, have to build, and to have to regulate. So we're talking again about cooperation. Do I have a few more minutes? Two? Huh? Okay. Okay. I'm going to thank you, but I'm going to take one more minute, and I'm going to just go a little bit further on this thing, is the requirements for adaptation. We have to have a long-term vision, and we have to have a long-term monitoring and documentation. That is, when these decisions are taken, we should be recording them. It's over a 50-year period, so that people can use this information. The organizational structure has got to be modified. Risk acceptance has got to be recognized. What are some of the barriers? Uncertainties. Maintenance of status quo. Let's do things the way we've been doing before, including some people who said, oh, I don't want to make any changes. If I make a change, I may get fired. I may get criticized by some association, etc. So you have to be able to create a situation where people are willing to and able to take the risk and make changes. I think that's about all I have to say. Thank you.